Hello everyone, welcome back to my YouTube channel. My name is Ved Prakash. Today we have something really exciting for all you aspiring machine learning engineers and data scientists out there. If you are gearing up for a machine learning interview, you are in the right place. In this video, we will be covering the top machine learning interview questions that you absolutely need to know to ace that interview. If you are new here or just passing by, please subscribe my channel and watch the video till end. But hey, before we get started, if you are really looking for in-depth explanations and resources, make sure to check out my blog geekycodes.in in the description below. So the first question is, what is supervised learning and what is unsupervised learning? Let's say hypothetically I am playing with a small kid of age 3. I took a tray and put 3 fruits in front of him. First fruit was red apples, second fruit was pink cherries, third fruit was banana. I am assuming that kid never saw these fruits and never ate them. He did not know anything about these fruits. Then I told him 100 times that this red fruit is apple, the pink fruit is cherry, and the yellow fruit is banana. I repeated and repeated. Here I provide my kid the input which is a fruit and the output which is called apple. The kid is able to learn that this red looking fruit is round is called apple. That is what we call supervised learning. Before you are giving input and output both, and machine learning machine needs to learn that how a particular input is mapped to a particular output. For example, Gmail spam or not spam classifier. Then what is unsupervised learning? Let's say I got another kid. I just showed him 3 fruits but did not tell him what fruit is called what. I'm sure after looking the tray multiple times, the kid will be able to differentiate that all the red fruits look same, all the yellow fruits look same, and so on. He won't be able to tell the name, but he will be able to put them in different categories based on the colors. That is called the unsupervised learning, where we give machine only the input. From the input, it needs to understand that the particular input belongs to which group or cluster. For example, credit card fraud detection. Next question is, can you tell me the difference between a data analyst and a data scientist? Let's say I'm an employee in Swiggy and my manager asked me to give the top 5 cities from where we are getting the least order in last 6 months. Now let's say Swiggy got 10 crore orders in last 6 months. To get the least order city information manually, it will take months. The answer to this question is already there in my data, but manually it's very difficult to find it. So here comes the role of data analyst who uses libraries like NumPy, Pandas, Matplotlib, even tools like Power BI or Tableau to find the answer. But let's say my manager said to me that give the estimated sale value of our company by the end of this year. Now here my job is to predict the sale value. This is data science or machine learning. You go to the past in data, it's data analysis. You go into future, it's data science. What do you know about data engineer? Let's say I'm using Ola and I booked a cab. Cab came to my door and I completed my trip. Now after 10 days, if I wanted to get any information about the ride I took, I can simply go and check on our Ola app. Now, how is every click on of mine is getting stored as data? What time I took my cab, my ride duration, price, and lot many other things. One job of data engineer is to create the pipelines of data and to get data stored in the cloud databases like MongoDB or AWS or Azure Data Lake. Define p-value and tell me why it is important. When scientists do experiments, they want to know if their results are actually meaningful or just coincidence. The p-value helps them make that determination. A p-value is a number that tells us that the likelihood that the results we see in an experiment are due to chance. The lower the p-value, the less likely it is that results are just a coincidence. For example, let's say a group of scientists is testing a new medicine. They give the medicine to one group of people and a placebo, fake medicine, to another group. Then they measure how many people in each group get better. If the group got the medicine has a much bigger, higher percentage of people who get better, the scientist can calculate the p-value to see if this difference is likely due to chance or if it is statistically significant. In general, data scientists consider a p-value of 0.05 or lower to be statistically significant. This means that there is a less than a 5% chance that the results are due to chance and they are probably meaningful. So the next question is, what is PDF and CDF and why do you think it's important in machine learning? PDF stands for probability density function. In probability theory, a PDF is a function that describes the relative likelihood of a random variable taking on a particular value or set of values. CDF stands for cumulative distribution function. It is a function that gives the probability that a random variable is less than or equal to a certain value. PDF and CDF are important because they allow us to model the distribution of data. By understanding the distribution of data, we can make more informed decision about how to process and analyze it. For example, if we have a dataset of images, we might want to know what distribution of pixels values look like. This information can help us choose appropriate processing techniques or models that take into account the structure of data. Now, can you explain the CLT, that is central limit theorem? The central limit theorem is a statistical concept that helps us understand how the means of random variables are distributed. It states that if we take a large number of random samples from a population and calculate the mean of each sample, the distribution of those means will be approximately normal regardless of the shape of the original population. For example, imagine we wanted to know the average height of all students in a school. We could measure the height of every student, but that would be very time consuming. Instead, we could take a random sample of students and measure their heights. We could then take the mean height of that sample and repeat the process many times, each time taking a different random sample of students. According to CLT, the distribution of those means would be approximately normal, even if distribution of heights in the original dataset was not normal. What are data structures and what data structures we have in Python? Data structure means that the way I can store my data. But the question is, why do I need different ways to store data? Is storing data in a single structure not enough? So yes, we cannot store the data into only one data structure because every data structure has its own advantages and its own disadvantages. For example, Python has four data structures. List. Now list is a mutable data structure, but it has on time complexity, which is not good, but has on space complexity. Tuple. Tuple is immutable and has the same search time complexity as list. Dictionary. Dictionary is mutable and also have O1 search time complexity but ON space time complexity. Set. Set is mutable because we can insert new elements into list. Set does not allow duplicates also. So, what are CNNs? Can you explain any CNN architecture? CNN stands for Convolution Neural Network, where the convolution means element-wise multiplication and addition. CNNs are generally used in computer vision problems where the basic problem is to generate vectors out of images. How would we gather information from an image to a mathematical vector? So we can use that information for problems like object detection or face recognition. There are some famous CNN architectures. LeNet is a convolutional neural network architecture that was developed by Jan LeCun and others in 1998. It was one of the first successful convolutional neural networks for image recognition and classification tasks. AlexNet is a convolutional neural network architecture designed in 2012. It won the ImageNet Large Scale Visual Recognition Challenge in 2012 and is widely considered as one of the breakthroughs that sparkled the deep learning revolution. VGG16. VGG16 is a convolutional neural network architecture that consists of 16 layers, including 13 convolutional layers, 3 fully connected layers. It was developed by the Visual Geometry Group at University of Oxford and achieved state-of-the-art performance on the ImageNet dataset in 2014. What is max pooling and why do we need max pooling. Max pooling involves in dividing an input image into a set of non-overlapping rectangular regions and then taking the maximum value of each region. The result is a downsampled version of the input image with reduced spatial dimensions. The primary reason for using max pooling is to reduce the size of the feature maps produced by convolutional layers in a CNN while retaining the most important features. This helps to reduce the computational complexity of the network, making it easier to train and faster process new input images. What is NLP? NLP stands for Natural Language Processing. It is a branch of artificial intelligence that focuses on teaching machines how to understand, interpret, and generate human language. It develops algorithms and models that can analyze and manipulate text, speech, and other forms of natural language data. It enables machines to perform tasks such as sentiment analysis, language translation, text summarization, chatbot conversation, and more. NLP is used in wide range of applications, from virtual assistants like Siri and Alexa to spam filters in emails, and even in healthcare for medical diagnosis and treatment planning. What are algorithms? To embed a sentence into a vector. Some of the algorithms which are used to embed a sentence into a vector is bag of words, TF-IDF, word to vector, word transfer, and GPT models. Tell us about your favorite algorithm. So you can tell it by telling your favorite algorithm. But here I have explained about random forest. Random forest is a popular machine learning algorithm that uses the concept of ensemble learning to build a robust and accurate model. Ensemble learning involves combining multiple models to make a prediction. In the case of random forest, multiple decision trees like decision tree 1, decision tree 2, decision tree 3 are built using randomly selected subsets of the training data and features. Each decision tree is trained independently, and the final prediction is made by the taking the average or majority vote for the prediction from all the decision trees. The random selection of subsets of data and features helps to reduce the impact of individual noisy data points or features on the model's prediction. And the combination of multiple trees helps to improve the model's accuracy and reduce overfitting. What is hyperparameter? In machine learning, a hyperparameter is a parameter that is set before the training process and begins and determines the overall behavior and performance of the machine learning algorithm. Hyperparameters are used to control the learning process and affect how the model is trained, such as the learning rate regularization parameter, number of hidden layers, number of neurons per layer, etc. The process of choosing the best hyperparameter for a given problem is known as hyperparameter tuning. So tell me about underfitting. What is underfitting? Underfitting is a common problem in machine learning where a model is unable to capture the underlying patterns and relationships in the training data, resulting in poor performance on both the training and test data. In simple terms, underfitting occurs when the model is too simple or not complex enough to represent the data. This means that model cannot learn the relevant features and relationships between the input variable and target variable. As a result, model produces high bias and low variance, and it performs poorly on both the training data and the new unseen data. So now explain about overfitting. Overfitting is a common problem in machine learning where a model is too complex and fits the training data too closely, resulting in poor generalization performance on new unseen data. In simple terms, overfitting occurs when the model is too complex and learns the noise in the training data, along with the underlying patterns and relationships between the input variables and target variables. This means that the model is not able to generalize well to new data and produces high variance and low bias, which leads to poor performance on new data. What is one hot encoding? One hot encoding is a technique used in machine learning to represent categorical data as a numerical data. It involves creating a binary vector for each category in a categorical variable. where each vector has a length equal to the number of unique categories in the variable. For example, as we can see here, the color column has red, green, and blue, and it has created three columns for three categories like red, green, blue, and then it maps accordingly. Like D1 is for red, D2 is for green, and D3 is for blue. Here, first row has red, then red column is mapped as 1, and in the second row green is there, so d2 column has been mapped as 1 in the second row, and accordingly, in simple terms, one hot encoding replaces each category in categorical variable with a binary vector that has a value of 1 in the corresponding index and a value of 0 in other all other indices. For example, suppose we have a categorical variable as I have explained here. What is multi-class classification? Multi-class classification is the task of predicting a target variable that has more than two possible outcomes or classes. For example, predicting the type of fruit in an image as either an apple, banana, or orange would be a multi-class classification. The main difference between binary classification and multi-class classification is the number of classes or categories in the target variable. In binary classification, target variable has only two classes, while in multi-class classification, the target variable has more than two classes. So now can we use all algorithms if we have multi-class classification problem? No, we cannot use all algorithms directly to use multi-class classification. We have used techniques like one versus all to make it work. For example, logistic regression is defined for binary classification, but we can use one versus all to make it used for multi-class classification. Now, what is the performance metrics that you will use if you have a model related, medical related problem like cancer prediction? One commonly used performance metrics in medical application is sensitivity, also known as the true positive rate. Sensitivity measures the proportion of an actual positive cases that are correctly identified as positive by the model. In cancer prediction, sensitivity is important because it reflects the ability of the model to correctly identify individuals who have cancer and who may require further medical evaluation. Another important for performance metric for cancer prediction is specificity, also known as the true negative rate. Specificity measures the proportion of actual negative cases that are correctly identified as negative by the model. In cancer prediction, specificity is important because it reflects the ability of model to correctly identify individuals who do not have cancer and who may not require further medical evaluation. What is F1 score? F1 score is a matrix that combines precision and recall to provide a single value that represents the balance between the two. It is particularly useful in binary classification task where one class is of greater interest than the other. Here is a short explanation of F1 score. F1 is equal to 2 star 2 into precision into recall by precision plus recall. You can call F1 score as harmonic mean of precision recall. Here, or you can say it like a TP upon TP plus half of FP plus FN, where TP means true positives, FP means false positive, FN means false negatives. So what is NLTK? NLTK is an open source software library written in Python that provides tools and resources for natural language processing tasks such as tokenization, stemming, tagging, parsing, and semantic reasoning. It also offers access to a vast collection of language corpora and lexical resources. NLTK is widely used in academia and industry for NLP research, development, and education. What is dropout? Dropout is a regularization technique used in deep learning neural networks to prevent overfitting. Overfitting occurs when a model becomes too complex and is trained to fit the training data too closely, which can cause it to perform poorly on new unseen data. Dropout works randomly dropping out, that is setting to zero, some of the neurons in neural network during training. This forces the network to learn more robust features and prevent any single neuron from becoming too important in making predictions. During the training process, each neuron in network is either dropped out with a specified probability or retained with probability 1 minus dropout rate. The dropout rate is typically set between 0.1 and 0.5, and the optimal value can depend on the specific problem and architecture of the neural network. What is batch normalization? Batch normalization works for by normalizing the output of each layer before applying the activation function. During training, the mean and standard deviation of the output of each layer are computed for each mini batch, and these statistics are used to normalize the output. Specifically, the output is normalized by subtracting the mean and dividing by the standard deviation, which is then scaled and shifted by learnable parameters called gamma and beta. Batch normalization has several benefits, including it reduces the dependence of the model on the initialization of the weights, making it easier to train deep networks. It also can improve the generalization performance of the model by reducing overfitting. It can make the optimization process more stable, allowing for the use of higher learning rates. What is a perceptron? Perceptron is a typical type of artificial neural network that is commonly used in machine learning for binary classification problems. It is a simple model that takes a vector of inputs, applies a linear function to the inputs, and produces a binary output based on threshold. The most commonly used activation function in perceptron is the step function, which produces an output of 1 if the weighted sum of the inputs is greater than or equal to a threshold, then 1, otherwise 0. Other activation functions such as sigmoid or ReLU functions can also be used in more complex models. How logistic regression is a single neuron model. It is a single neuron model in the sense that it is based on a single output neuron that applies a logistic regression, also known as sigmoid function, to a linearly combination of the inputs. In logistic regression, the input features x1, x2, xn are combined linearly using weights w1, w2, w3, and so on, and an intercept of b to produce a single output g equal to w1 x1 plus w2 x2 plus w3 x3 and wn x1 xn. In logistic regression, the input features x1, x2, x3 xn are combined linearly using weights w1, w2, w3, and so on, and an intercept of b to produce a single output z is equal to w1x1 plus w2x2 plus w3x3 plus wnxn plus b. This output is then passed through a logistic function to produce the predicted probability y hat of the positive class. Y hat is equal to 1 upon 1 plus exponential of z. Only one neuron is giving the output. That's why we call it a single neuron model. Why the name of logistic regression hedge regression when it is used for classification technique? The output of the logistic regression is y hat is equal to 1 upon 1 plus exponential of z. Y hat will always be between 0 and 1. So it will be any value between 0 to 1 which resembles regression. Classification means 0 or 1. Regression means any value between 0 to 1. So the nature of the output is regression, but then we take a threshold value to decide whether it is going to class 0 or class 1. That is why it is called logistic regression. For example, if output comes 0.8, then the threshold is 0.5, then we will say that because the value of output is greater than 0.5, then it belongs to class 0. What is a sigmoid function and why it is used in logistic regression? Sigmoid function is given by like 1 upon 1 plus exponential of x minus x. Sigmoid function is a differentiable function and has a probabilistic nature. It is used in logistic regression because it is taper off the outliers in the data. We use sigmoid function to squash the outliers from the data. What do you mean by a hyperplane and how hyperplane is important with respect to machine learning? Let's say I have a classification task and I want to classify two classes, spam or not spam, and I have only two features. Two features means geometry of the problem lies in 2D. Axis is a feature 1 and y-axis is a feature 2. Now if you see in the diagram here, if I want to classify two classes, I would need a line. If I got three features, then to separate these two classes, we need a plane. If I got more than three features, then I would need a hyperplane. In most of the machine learning problems, we have more than three features, and to solve that, I would need a hyperplane. I would need to know the equation of hyperplane because hyperplane is actually the decision boundary. So now what is backpropagation? Backpropagation is a way where we leverage chain rule of differentiation and memoization concept to find the derivative of the loss function with respect to the weights so that we can update our weights in update equation of gradient descent. Back, back propagation is the back of deep learning because at the end we need to find the weights to complete the training process. What is gradient descent? Gradient descent is an optimization algorithm used to minimize the cost function of a machine learning model. The cost function is a measure of the difference between the predicted output of the model and the actual output. The algorithm works by starting at a random point in the parameter space by the model and iteratively adjusting the parameters in the direction of steepest descent of the cost function, which is determined by the gradient of the cost function. The gradient is a vector that points in the direction of the greatest rate of increase of the cost function, and the algorithm updates the parameters in the opposite direction of the gradient in order to move towards a minimum of the cost function. Now, what is the problem with the gradient descent? While gradient descent is a widely used effective optimization algorithm for many machine learning models, there are some potential problems associated with it. Local minima. Gradient descent can converge to a local minimum of cost function, which may not be the global minimum. This can lead to suboptimal solutions that do not perform as well as they could. Second thing is learning rate. The learning rate determines the step size taken by the algorithm in the direction of the gradient. If the learning rate is too small, algorithm may converge too slowly. While if the rate is too large, the algorithm may overshoot the minimum and fail to converge. Now the next question is what is SGD? Stochastic gradient descent. SGD is a variant of gradient descent used for training machine learning models. It updates the model parameters after each individual training example or a small batch of examples. This makes the algorithm more computationally efficient and can lead to faster convergence. Stochastic gradient descent is commonly used for large datasets and deep learning models. Now explain the problem of vanishing gradient. The problem of vanishing gradients refers to a situation where the gradients of the cost function with respect to the model parameters become very small, particularly in deep neural networks, making it difficult to train the network effectively. When the gradients are too small, the updates to the model parameters during training become very small, and the network may converge to a suboptimal solution or not converge at all. The problem is particularly acute in deep learning neural networks with many layers, where the gradient can become exponentially small as they propagate through the layers. So now the next question is, what are the different activation functions used in deep learning? The first activation function is sigmoid. The sigmoid function maps any input value to a value between 0 and 1. It is often used in output layer of binary classification model. The next activation function is tanh. Tanh function maps any input value to a value between -1 and 1. It is commonly used as an activation function in hidden layers. Next, activation function is ReLU. ReLU function outputs the input value if it is positive and otherwise zero. It is widely used in deep neural networks due to its simplicity and effectiveness. The next one is leaky ReLU. The leaky ReLU function is a variant of the ReLU function that allows for a small positive gradient when the input is negative. This can help alleviate the dying ReLU problem where the gradients become zero for the negative inputs. Now, how to deal with the outliers in machine learning? Here are some techniques that can be used to deal with outliers in machine learning. First of all, we will detect outliers. Before dealing with outliers, it is important to first detect them. This can be done using various statistical techniques such as G-score, interquartile ranges, IQR, and box plots. The next step is removal. One approach to dealing with the outliers is to simply remove them from the dataset. However, this approach should be used with caution as removing too many data points can lead to a loss of information and biased results. What will you do if your model is overfit? Increase the size of the dataset. One way to reduce overfitting is to increase the size of training dataset. This can help the model generalize better to unseen data. Second thing is feature selection. Another approach is to carefully select the most relevant features that are likely to have a strong impact on model's prediction. This can help reduce noise in the data and improve the model's performance. The next approach is regularization. Regularization is a technique that adds a penalty term to the cost function during training, which helps to prevent the model from overfitting the training data. Popular regularization techniques include L1 and L2 regularization, dropout, and early stopping. Now, if you have enjoyed the video and you have got to know something better than you already did, then please subscribe to my YouTube channel and like the video, comment your views on it, and thank you for watching.